Hello everyone. The topic of today's lecture is the concept and influencing factors of equivalent calculation of funds. First, let's take a look at the concept of fund equivalence. 100. If you deposit 100 yuan in the bank now, 10%, with an annual interest rate of 10%, you can withdraw the principal and interest, totaling 110 yuan from the bank after 1 year. Why is it that when you deposit 100 yuan in the bank will give you 110 yuan after 1 year? This illustrates that the 100 yuan you deposited now is equivalent in value to 110 yuan 1 year later. In other words, with an annual interest rate of 10%, the present value of 100 yuan is equal to the future value of 110 yuan 1 year later. The concept of fund equivalence refers to the fact that, under the influence of interest rates, funds occurring at different time points and with unequal absolute values have equal economic value. The process of converting a fund amount occurring at one time point into an equivalent amount at another time point, using the concept of equivalence, is called fund equivalent calculation. Equivalence calculation is the foundation for time comparability when comparing multiple cash flow scenarios. Since the timing and amounts of fund expenditures or incomes differ for each scenario, it is necessary to convert all fund expenditures and incomes of each scenario to a specified time point, based on a certain time value of money, interest rate, and compare them on the premise of equal value. This conversion is called equivalent calculation, also known as fund equivalent conversion. It serves as an important basis for engineering and technical economic analysis, comparison, and evaluation of the effects of fund use at different times. Now that we understand what equivalent calculation of funds is, what are the factors that affect this calculation? First, fund amount. The fund amount is one of the factors that affect fund equivalence. A larger fund amount means a larger principal for equivalent calculation, with other conditions remaining unchanged. The result of equivalent calculation of funds, which we commonly refer to as the sum of principal and interest, or the return, will also be larger. Second, duration of fund occurrence. The duration of fund occurrence is another factor that affects equivalent calculation of funds, with other conditions remaining unchanged. The longer the duration of fund occurrence, and the later the time point for calculating the sum of principal and interest or return, the larger the result of fund equivalence calculation will be. Third, interest rate. The interest rate is the third factor that affects equivalent calculation of funds, with the first two factors remaining unchanged. A higher interest rate results in a larger outcome of equivalent calculation of funds, meaning a greater sum of principal and interest. In summary, there are three factors that affect fund equivalence: the amount of funds, the duration of fund occurrence, and the size of the interest rate, or discount rate. Among them, the interest rate is a key factor, and the same interest rate is generally used as the basis for equivalent calculation. In engineering economic analysis, equivalence provides evaluators with the possibility to assess the effectiveness of an economic activity, or to compare and select technical schemes, because when considering the time value of money, incomes or expenditures occurring at different times cannot be directly added or subtracted. However, using the concept of equivalence, funds occurring at different time points can be converted into equivalent funds at the same time point, and then compared. Therefore, in engineering economic analysis, the comparison of technical schemes is analyzed, evaluated, and selected Using the concept of equivalence. Using the concept of equivalence, a fund amount occurring at one time point can be converted into an equivalent amount at another time point. This process is called equivalent calculation of funds, which typically involves calculating the present value, future value, and annual equivalent value of a series of cash flows. Present value calculation. Converting a fund amount, or a series of fund amounts at a future time point, into an equivalent amount at an earlier time point, is called discounting the fund amount after discounting the funds at a future time point is called the present value, PV. Future value calculation. Converting a fund amount occurring at any time into an equivalent amount at a later time point. The fund amount at a future time point is referred to as the future value, FV. Annual value calculation. Converting a fund amount occurring at any time into an equivalent amount that is the same at the end of each period. The symbols used are defined as follows. I. Interest rate. N. Number of interest periods. P. Present value. F. Future value. A. Annual value. Now, let's delve into the calculation of single payment, future value, FV, and present value, PV, in equivalent calculations. The term single payment refers to a scenario where only one cash flow occurs within the entire analysis period. This involves the conversion between present value, P, and future value, F. First, for the calculation of single payment future value. As we mentioned earlier, this is essentially the formula for compound interest. When the initial investment is P, the interest rate is I. Find the principal and interest recovered at the end of year N and F, terminal value. It can be expressed as F equals P multiplied by left parenthesis 1 plus I right parenthesis raised to the power of N equals P multiplied by left parenthesis F over P I N right parenthesis left parenthesis E plus I right parenthesis raised to the power of N. The formula introduces the single payment future value factor. It can be expressed as the formula introduces the single payment future value factor, denoted as F or P, I, N. It's important for you to note that in coefficients like F or P, I, N, the symbol before the slash in the parentheses represents the unknown value that needs to be found, while the symbols after the slash represent known values. Furthermore, coefficients like F or P, I, N can be directly looked up in the appendix tables provided in our textbooks without the need for additional calculations. To find the correct coefficient, first locate the table corresponding to the given interest rate, and then find the required coefficients in the column corresponding to the number of periods N. Let's look at an example. A loan of 2 million yuan is obtained with an annual interest rate of 10%. What is the total principal and interest that needs to be repaid after 10 years? This is the calculation of the total principal and interest we discussed earlier, also known as the single payment future value calculation. The 2 million yuan is the present value P, which is known, and the total principal and interest, or future value F, is what we need to find, denoted as F divided by P, I, N. After looking up the coefficient in the table, we get left parenthesis F over P, 10%, 10 right parenthesis equals 2.5937. So, F equals P multiplied by left parenthesis 1 plus I right parenthesis raised by the power of N equals P multiplied by left parenthesis F over P, I, N right parenthesis equals 200 multiplied by left parenthesis 1 plus 10% right parenthesis to the 10th power equals 200 multiplied by left parenthesis f over p. 10%, 10 right parenthesis equals 200 multiplied by 2.5937 equals 5.187 for left parenthesis million yuan right parenthesis. In other words, the total principal and interest that needs to be repaid after 10 years is 5.1874 million yuan. Let's continue with the examples. A company invests 15 million yuan with an annual interest rate of 10%. How much will the principal and interest amount to after 5 years? Given the present value P of 15 million yuan, we need to calculate the future value F. After consulting the table, we can obtain F or P, 10%, 5 equals 1.6105. F equals P multiplied by left parenthesis 1 plus I right parenthesis to the power of n equals P multiplied by left parenthesis F over P. I, n right parenthesis equals 1500 multiplied by left parenthesis 1 plus 10% right parenthesis to the 5th power equals 1500 left parenthesis F over P, 10%, 5 right parenthesis equals 1500 multiplied by 1.6105 equals 24.1575 million yuan. If a company invests 15 million yuan with an annual interest rate of 10%, the total principal and interest after 5 years will be 24.1575 million yuan. Someone lends 10,000 yuan to a friend at an interest rate of 10% per annum, calculated on a simple interest basis for 3 years. After 3 years, the interest is changed to compound interest, and the friend uses the money for another 4 years. How much principal and interest will they finally recover from their friend? In this problem, there is both simple interest and compound interest. Therefore, we need to first calculate the principal and interest for the first 3 years using simple interest, and then use this as the principal for the next 4 years of compound interest. The total of principal and interest for the first 3 years equals 10,000 multiplied by left parenthesis 1 plus 10% multiplied by 3 right parenthesis equals 13,000 yuan. For the next 4 years of compound interest, after consulting the table, left parenthesis F over P, 10%, for right parenthesis equals 1.4641. We have left parenthesis F over P, 10%, for right parenthesis equals 1.4641. F equals P multiplied by left parenthesis 1 plus I right parenthesis raised to the power of n equals P left parenthesis F over P. I, n right parenthesis equals 13,000 left parenthesis 1 plus 10% right parenthesis raised to power of 3 equals 13,000 left parenthesis F over P, 10%, for right parenthesis equals 13,000 multiplied by 1.4641 equals 190.333 million yuan. So, the final principal and interest recoverable from the friend is 19,033. 3 yuan. Let's take a look at the present value calculation for a single lump sum payment. Suppose that in n years from now, you will need or receive a fund F, and the interest rate is I. We need to calculate the investment P required at the beginning. In the formula, we need to calculate the investment P required at the beginning. P equals F multiplied by left parenthesis 1 plus I right parenthesis to the power of minus n equals F multiplied by left parenthesis P over F. I, n right parenthesis. In the formula, left parenthesis 1 plus I right parenthesis raised to the power of minus n is called the present value factor for a single lump sum payment, denoted as left parenthesis F over P, I, n right parenthesis. F equals P multiplied by left parenthesis F over P, I, n, right parenthesis and P equals F multiplied by left parenthesis P over F, I, n, right parenthesis are inverse operations of each other. Left parenthesis F over P, I, n, right parenthesis. Left parenthesis p over f, I, n, right parenthesis are reciprocals of each other. Someone plans to receive 100,000 yuan from the bank in 5 years. If the bank interest rate is 12%, how much money should be deposited in the bank now? In this example, the future value f is known, and we need to calculate the present value p. This is the inverse of the previous present value calculation. For a single lump sum payment, after consulting the table, we find that equals 0.5674. Therefore, P equals F multiplied by left parenthesis 1 plus I right parenthesis raised by the power of minus n equals F multiplied by left parenthesis P over F, I, n right parenthesis, equals 10 multiplied by left parenthesis 1 plus 12% right parenthesis raised to the power of minus 5, equals 10 multiplied by 0.5674, equals 56.7 thousand yuan. In other words, with an interest rate of 12%, if you want to receive 100,000 yuan in 5 years, you need to deposit 56,700 yuan in the bank now. A company plans to invest in a project in 5 years, and will need 10 million yuan at that time. If the annual compound interest rate at the bank is 5%, how much principal needs to be deposited now in one lump sum? After consulting the table, we find that the present value factor left parenthesis p over f, 5%, 5 right parenthesis equals 0.7835. Therefore, p equals f multiplied by left parenthesis 1 plus I right parenthesis raised by the power of minus n equals f multiplied by left parenthesis p over f, 5%, 5 right parenthesis, equals 1000 multiplied by left parenthesis 1 plus 5% right parenthesis raised to the power of minus 5, equals 1000 multiplied by left parenthesis p over f, 5%, 5 right parenthesis, equals 1000 multiplied by 0.7835, equals 7.835 million yuan. In other words, with an interest rate of 5%, if you deposit 7,835,000 yuan now, you will have 10 million yuan in 5 years. That's all for this video. Thank you, everyone.